This is section 9.4. Section 9.4 talks about the preparation of alkynes. We haven't gone over many reactions about alkynes specifically, or much of chapter 9 specifically, and that's because alkynes undergo so many reactions that are like alkenes. However, preparing alkynes is a little different than alkenes in that typically you have some alkyl dihalide and you add strong base, two equivalents of strong base, and you end up getting the alkyne. And you name alkynes just like you would alkenes, except instead of the parent having the name ene, now the parent has the name yne, Y-N-E. So this molecule would be called 1-butyne, 1, 2, 3, 4 in the parent chain, because it has an alkyne. And besides changing the ene to yne, all other naming protocols, the IUPAC naming protocols for alkenes, we follow. Now, the mechanism of how this happens is fairly straightforward. You have the dibromide or the dihalide here. A strong base comes and takes one of the beta carbon's protons and eliminates a bromide in an E2 fashion. E2, to make a vinyl halide intermediate. That vinyl halide can also react with a strong base and eliminate the last halide, such as the bromide in this case, in another E2 reaction to give us finally the alkyne. And what's interesting is the dihalide could be either geminal dihalide. Geminal means that the two halides are on the same carbon, or a vicinal halide, meaning, vicinal dihalide, meaning that the two halides are in the same vicinity or on carbons next to each other. So if you notice, each bromide is on a neighboring carbon. So we call those vicinal dibromides. Also, we could use the other geminal dihalide to make the alkyne here. Either of these three products could give us the desired alkyne that we're looking for. And typically, the strong base that we use in these reactions is sodium amide or sodium amide, and the solvent we use is typically liquid ammonia. And we do this because of the pKa of the alkynes and the fact that sodium amide is a strong base, but ammonia is not that strong of a base. It's still pretty strong, but it's not as strong as sodium amide. So if you do this reaction, you end up getting just the terminal alkyne here. And that was section 9.4.